Hello, everyone. Welcome back. Today, we're going to talk about the quadratic formula, how we can use the quadratic formula to actually solve quadratic equations. So our goals are to be able to use the discriminant, which is part of the quadratic formula, determine the type of solution of a quadratic equation, and then be able to use the quadratic equation to actually solve, or quadratic formula to actually solve a quadratic equation. Let's look here on the left. So what a quadratic equation is, a quadratic function is, or actually, sorry, this should even actually correct that. It should be equation, not function. And something looks in general looks like this, or can be written this way, where it's called quadratic because your highest power is x squared. And also all your powers are whole numbers or things like that. There are no negative powers, no x's under square roots, no x's in the denominator, or anything like that. And also these a, b, and c are all constants. Now, we also say that a can't be 0, because if a is 0, this first term is gone, it's no longer quadratic. Now, a way to solve the quadratic equation like this is by the quadratic formula, and that's this right here. So it's given by this, once again, in terms of these a, b, and c's. So it's negative, it says that x is equal to negative b, then plus or minus, since it's quadratic, we expect to have generally have two solutions. So 1 plus and 1 minus, divided by, or times, and then the square root of b squared minus 4 times a times c, then everything is divided by 2a. And this is the quadratic formula. Now, this solves any quadratic equation. It doesn't necessarily mean it's always the best one to use, or the simplest one to use. It can solve any quadratic equation. And once again, as long as a is there, if you notice if a was 0, your denominator would be undefined. So that's another reason why a has to be there. It also says to use the quadratic formula, the quadratic equation must be written in the form above. So basically, you have to make sure it's written like this, where one side is equal to 0, and generally, preferably written in this order, where you have the square term first, then the x term if there is one, and then the constant if there is one. Now, also here's some general ways to solve a quadratic equation using the quadratic formula. First, simplify both sides. Sometimes that may not be true, so simplify both sides first, okay? And set one side equal to 0, so make it look like this as much as possible. Divide both sides by any common factors. That'll just make it easier to work with. And also, if the coefficient from the squared term is negative, if a is negative, divide both sides by -1. This is more of a choice, just makes it once again easier to work with. You can do it if it's negative, but it just makes it better to deal with. Then once you've done all that, once it's in this form, determine what a, b, and c are. So once again, a is the coefficient from the squared term, b is the coefficient in front of the x term, the single variable term, and c is a number by itself. Also include the signs in front of it, whether positive or negative. Okay. Also, as this says, the b and c are optional. They can be 0, but a has to be there. A can't be 0. Then plug all three, plug the ones that you have into the quadratic formula, and simplify. This also includes simplifying roots, things like that. All right. Now, before I actually look at the first example, let's also talk about something called the discriminant. So if you look at this term under the square root, it says b squared minus 4ac, that's called the discriminant. And what that means, and what it does, it allows us to tell what types of solutions a quadratic function has. So basically, you'll plug this in and find that number. That number is greater than 0. You have 2 real solutions. If it turns out to be equal to 0, which is rare, but if it does, you have only 1 real solution. Then if it's negative, there are 2 complex solutions. By complex, I mean solutions involving I. Now, actually, in solving, we're not going to solve any with complex solutions today. Or at least we see any, we're not going to finish solving them. That will come another time. But that tells you what kind of solutions you have. You want complex solutions. Okay, so let's look at our first example. So over to the right. And so our direction is, let's just say direction is to solve. Number 1. So let's say we have an equation x squared plus 5x plus 6 is equal to 0. Okay. Now this is one you can also solve by factoring if you know how to do that. But if you don't, you can always solve it with a quadratic formula. And this one's already in the form we want. Okay, one side's equal to 0. And we have our all our terms kind of in ascending order. So a is the number in front of the squared terms. In this case, a is just a positive 1. B is the number in front of the single variable term, in front of the x, and that's plus 5 or positive 5. Then finally, C is the number by itself, which is positive 6. So now we plug all those into our quadratic formula. So x will be equal to negative b, and b is right here, 5. Then plus or minus, once again, since in general, quadratic equations generally have two solutions, that's where the plus or minus comes in. Now, under the radical sign, we have b squared, so 5 squared minus 4 times a, which is 1, times c, which is 6. Where this is all under the square root. Then everything is divided by 2 times a, or 2 times 1. Now, then the final part then is simplifying. And sometimes this can be, not necessarily difficult, but it's often where the most mistakes are made. So always be careful with this. So now just simplify. So we still have negative 5 plus or minus the square root of 5 squared is 25. Then minus 4 times 1 times 6 is 24. This is all over 2. Okay, just continuing to simplify. So negative 5 plus or minus the square root of 1 over 2. Of course, we know the square root of 1, that comes out evenly. And so this is going to be negative 5 plus or minus the square root of, or plus or minus 1 over 2. Now, at this point, what we do is want to separate these. Now, since there are no more radical signs, no more square roots, it means we can write this in a better way. So make sure you separate them out. What I mean by separate is using our plus or minus. So it doesn't matter which one we do first. So 1x is going to be negative 5 plus 1 over 2. And the other will be negative 5 minus 1 over 2. Okay, then just simplify each one of these. Negative 4 over 2. So this x then is negative 2 over here. And so we have negative 6 over 2. And so this x then is negative 3. And those are our two solutions. And once again, that's now, if you know how to factor quadratic equations, the ones that can be factored, not all can, this is one actually can be factored. Factoring is quicker, but this will always work. So if you don't remember how to factor or have trouble factoring, you can always use a quadratic formula. Okay. Now, also one thing I should mention, our discriminant in this case was equal to 1. So remember, the discriminant is what's under the square root. That was 1. Okay. And that was greater than 0. And so that told us that we had two real solutions, which we do, negative 2 and negative 3. Okay, so that's our first example. Let's take a look at another one. So number 2. And give me a moment, let me choose the one I want. Okay, let's do this one. X squared minus 6x plus 9 is equal to 0. Actually, this is another one that would factor, but let's take a look at this one, and also something else you'll see that happens. Okay, once again, this is also in the correct form we want. Okay, so everything, one side's equal to 0. They have the squared term, then the constant, the single variable term, then the constant. So once again, a, the number in front of the squared term, is positive 1. B in this case is negative 6. So make sure you include the signs. And then C is a number by itself, which is positive 9. So once again, plug these into the quadratic formula. So x is equal to, now the formula here, this negative is part of the formula, but b itself is negative. So be careful with that. It's easy mistake to make. Then plus or minus, then the square root of b squared, so minus 6 squared, then minus 4 times a, which is 1, times c, which is 9, not 6, 9. Actually, let me write a better, let me write this better. Okay, 4 times 1 times 9. Okay, then everything is over 2a. So make sure you remember that everything is over 2a, including this part. So 2 times 1. Okay, just as before, I want to simplify everything. So here, a negative times negative is positive. So we have positive 6 plus or minus the square root of negative 6 squared. Since we're squaring the negative as well, this is going to be positive 36. Then minus 4 times 1 times 9 is also 36. So over 2. Now, if you notice, of course, 6 plus or minus the square root of 0, okay, over 2. Now, also, our discriminant in this case, let me write over here to make it note. So discriminant is equal to 0. Okay, let's review that. So the discriminant, what it says, is if what's under the radical sign, the one we just saw, a previous one, if it's greater than 0, the two real solutions. This time it's 0. It means there is only one real solution. And we'll see why. So let's go back, finish this one off. Okay, of course, the square root of 0 is 0. So 6 plus or minus 0. And 0 isn't plus or minus. 0 is just simply, it doesn't have a sign. And so this just becomes, oops, over 2. This simply becomes 6 over 2, which becomes 3. So once again, this is our only solution. Sometimes called a repeated. Sometimes we see it called a repeated root. Okay, this is our only solution. Now, that's kind of rare, but that does happen sometimes. In fact, let's go to Desmos, and let me show, possibly graph both of these. Okay, yeah, so let's actually go ahead and graph the first one we did, which was x squared plus 5x plus 6. And what happens if you graph this as a function, not as an equation, but as a function, it turns out that your solutions, the function, your solutions are the zeros of the quadratic function. Okay, so that was our first one. Now let's graph this one. Now the reason why you say it only has one solution, let's see what happens. So x squared minus 6x plus 9. Okay, see that where it touches the axis there, where this is equal to 0, is only 1 point, 3, 0. So that's something true of also quadratic functions, is where they're equal to 0. Okay, if that's your, those are your x-intercepts. And so in this case, this one only has one x-intercept. This one only has one solution. Okay. Let's take a look at our third example. Okay. Let's say this time we have one that looks like this. So let's say we have negative 6x squared plus 5x equals negative 21. Okay, let me double check, make sure that's what I want. Okay, right. Now, if you notice, this is not in the right form. Okay. So what we first want to do is want to put this, I want to say put it in correct form. And basically, what we need is to make it look like this. Okay, a few things to do. So one thing, we need to make one side equal to 0. So it's easiest to make this side equal 0. So add 21 to both sides. And so we're going to have then is 0. We have negative 6x squared plus 5x plus 21. Okay. Now, let's do one more thing. And this is optional. But actually, I'm going to divide through everything through by -1. This is optional, but it makes it easier to work with, because if not, your a is going to be negative, and sometimes that can be complicated, especially in the denominator. So I think it's easier to do that. So we divide everything through both sides by -1. What that does, that changes all of our signs. Okay, so on the right, of course, 0 divided by -1, or 0 divided by anything except itself, is 0. This changes all our signs. This becomes then 6x squared minus 5x minus 21 is equal to 0. And now this is in a form that's best to work with. So once again, pick everything. So a is the coefficient in front of x squared, which is 6. B is the coefficient from the single variable term. In this case is negative 5. And C is the coefficient by itself, which is negative 21. Okay. Now, go through then, and once again, plug all these in. So we have that x is equal to, should be an arrow. All right, so negative, this is part of the formula. And once again, we have a negative b, so negative 5, plus or minus square root of b squared, or negative 5 squared, okay, minus 4 times a, which is 6, times all right, just checking something here. Okay, actually, hang on just a minute. Yeah, okay, right. So negative, yeah, good. Okay, there we go. I'll explain that in just a moment. Okay, and so negative 4, this negative is part of the formula, times 4 times 6 times negative 21. Okay, now, and then all over 2 times a, which is 6. Okay, once again, simplify. So negative and negative is a positive, so positive 5 plus or minus the square root. Okay, negative 5 squared is positive 25. And what I was concerned about is I thought this whole thing is going to be negative, and that would make this a negative under the square root, which would mean we have a complex solution, but actually we don't. It's going to be positive, so negative times a negative. And also just multiply this through. So 4 times 6 times 21 plus 504. This is over 12. Okay. Okay. Now, let's take a look at what's under the square root. And so this, if I combine these, that's positive 529. Now, 529, our discriminant, I'll abbreviate that, is that number 529. And what that tells us then, this is positive, is greater than 0. So we have 2 real solutions. Now, discriminant doesn't tell us anything about what kind of solutions we have, other than the fact they're real. Okay. And then this is still over 12. Now, okay. Now, actually 529 turns out is actually a perfect square. And so that turns out it's actually 23. So this is much like the very first one we did. Okay. So we want to separate these if possible, and separate this into, so this is our x. So separate them with a plus or minus. And so I'll just write that. So separate. Okay. So one is 5 plus 23 over 12. The other is x equals 5 minus 23 over 12. Okay. Then, of course, just combine those. It's going to be 28 over 12, which we reduce. Divide both by 4, in fact, that's going to be 7/3. And over here, 5 minus 23 is going to be minus 18 over 12. And we can divide both those by 6. That's negative 3 halves. Okay, so those are our 2 solutions. And if we graph that, we'll see that. Okay, so here we have 6x squared minus 5x minus 21. Okay, and there are 2, you can check, but there are 2 solutions right there. We round them off. Okay. All right, let's take a look at our next example. All right, this one once again is a little bit different. Let's also use a different variable this time. So we have w squared. Of course, a variable can be anything, equals 3 times w minus 1. Okay, now, once again, we want to get this in the correct form. And once again, by correct form, we mean make it look like this. Okay, so the first thing we want to do, following a general, this is true if you have any kind of equation, simplify both sides first. So distribute the 3 over here. So the left side is good as it is right now. Then we have going to have 3w minus 3. Now, I want to make one side equal to 0. So I think the easiest thing, like I say, generally want our square term to be positive. So I'm going to move all these terms over here. And so if I do that, then I'm going to have w squared. Then subtract 3w from both sides. Add 3 to both sides. And so that then is in the correct form. Okay. Now, same thing as before. A, B, and C. So A is the coefficient from the squared term, which is 1. B is the coefficient from the negative variable term, which is negative 3. And C is the coefficient by itself, which is positive 3. Now, plug all these in. This time it was W, not X. So we have a negative as our part of the formula. And B is negative 3, plus or minus the square root of B squared, so negative 3 squared, minus 4, better 4, times A, which is 1, times 3. This is all over 2a, or 2 times 1. Okay. Now, simplify again. Negative times negative is positive, so positive 3, plus or minus the square root. Negative 3 squared is positive 9. Then minus 4 times 1 times 3 is minus 12 over 2. Okay. Now, something a bit different will happen this time. So 3 plus or minus the square root of negative 3 over all over 2. Now, this time our discriminant, what's under the radical, is negative 3, which is less than 0. It's negative. Okay. So what this means is, we haven't seen this before in this video. Now we have, this tells us then we have 2 complex solutions. Okay. Now, this is something that you may not have seen, I haven't shown in this video, may have seen in another video. I've actually had to deal with complex numbers or negatives under the square root. What we're going to do then is actually first convert this what's called I form. So write this as a 1, or sorry, I times the square root of 3. Okay, so we'll go converting it to I form. Okay, then over 2. And then finally, we want to, generally with complex solutions involving I want to separate this out in what's called the real and imaginary part. So just make 2 fractions out of this. So we have 3 plus or minus, or not plus or minus, sorry. Plus or minus I times the square root of 3. So sorry, 3 over 2. And then this over 2. Okay, we still have 2 solutions. This is W, so our 2 solutions. You can still write them separately if you want. You don't have to, though. Is 3 halves plus square root of 3 times 2 times I. It's often written this way. This is called the real part. This is called the imaginary part, the number from the I. And also W is equal to 3 halves minus the square root of 3 over 2 times I. And those are our 2 solutions for this example. Okay, let's do one more example. And actually, give me just a second. I need to alter what I had planned. Okay. do this. So we have, let's say this time we have, it's not y this time, y squared minus 2y, then minus 11 is equal to 0. Okay. Now, so once again, this one's already in the right form. So a is the coefficient in front of the squared term, which is 1. B is the coefficient in front of the single variable term, which is -2. And C is the coefficient by itself, which is -11. Right? And then plug all these in. And this time we're solving for y. Y is equal to a negative. And of course, our B is -2 plus or minus square root of -2 squared. Okay. Then minus 4 times A, which is 1, times C, which is -11. And it says everything is over 2 times 1. Okay, once again, simplify. So it becomes a positive 2 plus or minus the square root. And then -2 squared is positive 4. Then this is going to be positive because negative times negative is positive, plus 4 times 1 times 4 is 44. And then this is all over 2. Okay. Now I chose this one. Let's see, we have to do a little more simplifying. Okay. Now, once again, let's simplify what's under the radical sign. So 2 plus or minus the square root of 48 over 2. Okay. Now here, this time, our discriminant is the number 48, which of course is bigger than 0. And once again, what this implies is we have 2 real solutions. Okay. Now, I also want to see this because this is one we have to simplify. Okay. So 48 is not a perfect square, but there's a perfect square in it. And actually, there are a couple in it. And the largest one is actually 16. 48 is 16 times 3. Right, like that. And this is still over 2. Okay. And then if you recall, you've seen this before, then since we're multiplying, we can break this up into the square root of 16 times the square root of 3, still over 2. And what that becomes then is that becomes 2 plus or minus square root of 16, of course, is 4 times the square root of 3 over 2. Now, square root of 3, we can't simplify anymore, so we're going to leave it as the square root of 3. Now, let's do one more thing, is we can still simplify this a bit. Okay, you notice we have a 2 here. This is, we're dividing by 2. There's a 2 here and a 4. You divide both by 2, so you can either factor a 2 out, but I think the best thing to do is actually to make 2 fraction. So this is 2 over 2 plus or minus 4 times the square root of 3 over 2. And then this becomes just 1 plus or minus 2 times the square root of 3. Okay, so once again, we have 2 solutions. And this is y. Now let's actually look at both separately. So y is equal to 1 plus 2 times the square root of 3. And y is equal to 1 minus 2 times the square root of 3. And I'm writing this way. Let's approximate those, and we can actually approximate these, of course, you can with a graphing calculator, regular calculator. We can also do it with Desmos. Okay, let's go to Desmos again. So you may not know this, but you can do calculations with Desmos. So if I do 1 plus 2, then to get a square root, I can either find it here, it's keyboard. There's several functions, but it's square root right here. Okay, or I can also just simply type in SQRT, lowercase, give me that. If I type that in, that gives me an approximation for that. Now let's actually copy this, and I'll just change it slightly below. And this way we can also approximate both values, because often that's really useful to be able to approximate them. Okay. And so the first one is approximately 4.46. The second one is approximately -2.46. So the first one's approximately 4.46. Is -2.46. Let's double check that again. Okay, and also we could graph these, graph this one. And so remember what this was. This was my original problem. Now I'll use x in Desmos. So y squared minus 2y minus 11 So in Desmos, I'll write it as using x squared minus 2x minus 11. All right, so there are both of our zeros, as we said. Okay. All right, so let's take a look at what we've learned so far. So what we learned today is that to solve a quadratic equation looks like this. We can solve any one of them using the quadratic formula. Now, that's not always the best or easiest way to solve, depending on your equation, but we can always use it. We looked at a couple of situations and using the discriminant, what's under the radical sign. We found that the discriminant then tells us if what's under the radical sign is positive, there are two real solutions. If it's equal to 0, which is rare, but still can happen, there's one real solution. If it's negative, there are two complex solutions. Here, complex meaning that you have to deal with the square root of a negative number. So we learned then how to solve equations, also how to get the equations in the correct form, how to solve them with the quadratic formula, and also how to simplify our answers. Thank you. Have a good day.